Okay, so how is everyone today? Good, I hope. All right, so last time we were talking about square root, so let's pick that up again. So let f of x be the square root of x. We want to ask several questions about it. So the first question is, what is its domain? To answer this question, you have to remember the rule that when a function is given, sometimes the domain is explicitly given, something like let f of x be this function with that domain. But when the domain is not explicitly given, the domain of the function is the natural domain of the expression defining it. So no domain explicit, and therefore the domain of f is the natural domain of square root of x, and that requires you to go back in time when we discussed that in the first place. So what is the natural domain of the square root of x?
Greater than or equal to 0?
Correct. So x greater or equal to 0. As an interval notation, you could write 0 to infinity. And as a plot, you could either draw just the line segment, but for reasons that what I mean is you could just draw the part from 0 to infinity. But for reasons that will become clear in a minute, I'm going to draw the whole. I'm going to do it in the other style, and say and draw the whole thing, but shade in the part that we're referring to. Okay, so that's the domain. Yes?
Statement. The term natural domain, I really never did quite understand the natural part of it, but in this context, it makes sense. Like, the word natural has more of a meaning here.
Yeah, I agree. It's kind of unfortunate, like that for half of the semester we use the adjective natural. Well, why? You know?
Right.
Because if you're going to say something like a natural domain, then is there an unnatural one?
And not just use the word domain like
Right.
prior to it.
Yeah, I agree. It's not. The terminology is not set up perfectly for teaching and learning. Okay. The range. Well, you've got to remember the rule. So no range was explicitly given, and therefore you've got to remember what explicit. You've got to remember the rule. So you say therefore the range of f is all of the reals. Is reals. So again, algebraically, considering the input symbol x and the output symbol y, algebraically you could write negative infinity less than y less than infinity, so that you could write it as an inequality. As an interval notation, you could write it negative infinity to infinity. And then to make a plot, you could draw the whole number line, but to try and make it as clear as possible, I'm going to draw this number line vertically oriented because, well, the inputs are horizontally oriented and the outputs are vertically oriented. So it's the whole thing. So there's 0 if you like. I'll put it right there, and we get all of it. Okay. Domain, range, 3, image. Okay, so now that we have all three of these words written on the page, domain and range and image, I will remark that historically it has been my experience that students have difficulty separating the concept of range and image. So to remind you of the distinction, domain, to make the vending machine analogy, the domain is the set of all buttons which are installed. Because after all, maybe it doesn't have every conceivable button. So just outside the door, in fact, is a vending machine. And, I might ask, I could say, I could request of you, does it have a button number 8? And you could go over and say, yep, I found it. Then I could ask, does it have a button numbered 8 million? And then you go over there and check, and nope, doesn't have a button 8 million. So that would mean that 8 is in the domain of that vending machine, where 8 million is not. The range, to make the vending machine analogy, this is the set of items on display. So the set of displayed items. So then there's the distinction between the range and the image. So can someone remind us what the image is in the vending machine analogy? It is the set of items wired to buttons. That is to say, a normal, a typical person would probably consider it an error, but in principle it's possible for there to be like 15 items on display, but in fact only 8 buttons, so that 7 of the items can't even be gotten. Why are they on display? You might reasonably ask. Why even put them on display? Okay, so the image is the set of all things you could get if you pressed every button. All right, so now for the square root, we want to compute. We want to figure out what the image is. Okay, so from a plot point of view, we could plot it. So let's make a table first, a table of values. Just to sort of give us an idea. Well, as far as installed buttons, that is to say the domain, the least value that's in the domain is 0. It doesn't make sense for me to ask about any lesser one, so I'll do 0, 1, 2, 3, 4. So if you press button 0, that is to say evaluate square root of 0, you get a 0. Square root of 1 is 1. Square root of 2 is about 1.4. Square root of 3 is about 1.7, and square root of 4 is exactly 2. If we plot those points now, we'd see the following. Then if we plotted lots and lots of points, the following picture would begin to emerge. So that's the plot of y is square root of x. So, I have a question. This is, in fact, all of the plot. Why are we not plotting anything on the left side of the axis? Notice that it's all on the right. Did I just forget? Right. There's nothing over here. There's no domain over here, which is to say, you know, we could go over to that vending machine, and I could ask, you know, I could remark to you and say, I wonder why no one ever presses button -7. A reasonable thing would be to say, well, primarily because there's not a button -7. That's probably the main reason. Okay. Good. So there's no plot over here. So the question that we're trying to address is, what's the image? So that is like saying, you know, you could go to a vending machine and you could point at an item on display and say, I wonder if that item is in the image. One way you could do it is you could keep your eye focused on that item and press the buttons one at a time, bump, 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 and just exhaust all the buttons. If there's a button which gives it to you, then that item is in the image. If you press all the buttons and none of them yields for you that item, it's not in the image. So the range, remember, is all numbers. All numbers are on display. So how about say this number, -6 is on display. And the question is -6 in the image? It is in the range, but is it in the image? And the answer is no. The answer is no, because if you draw this, this line, y equal -6, the question of is -6 in the image visually is asking, do the plots of y equal -6 and y equal square root of x intersect? So do they intersect? The answer is no. So for this question, there is no for this line, there's no intersection. And therefore, we can answer the specific question, is -6 in the image? It is not. All right. Now, all of these items are on display. Here's an item that's on display. Item 2 is on display. Is 2 in the image?
Yes, I think it is.
It is, because now you draw this line again. And you ask the same question concerning this line, y equal 2, and the plot of y equals square root of x. Is there an intersection? And the answer this time is yes. There is an intersection, which means that there is a button to press. But what button is it that you press? You have to press button 4. And you can see that from the plot by saying, oh, there's where the intersection is, and that occurs at 4. So for this one, there is one intersection. So we could say to the question, is 2 in the image? The answer is yes. Is in the image. So, visually speaking, the answer to the question of is it in the image is visually understood by saying, well, let's draw a horizontal line and ask, is there an intersection? So how about -3 right here? Is it in the image? No. Right, so the answer is down here it's no, yes, right? That's the first place. That's the first yes. Then can you see that from that point on it's yes? It's going to start, the intersection, that is going to start moving to the right quite quickly. Like you can't see one anymore, but that's just because I can't draw the whole thing, right? It goes over there. All right. As a result, you can tell me what the image is.
Any number greater than 0.
You left one out.
And 0.
And 0. So it's all of these, right? So that is to say the image is y greater or equal to 0, which you could write as an interval like this, 0 to infinity. And then you could plot it in this way. You could plot it like this. So there's all of the reals and 0, but in fact we only get this much. So that's the image. All right. So that's how to consider the question of image from the point of view of a picture. But here's a different way, because some people aren't picture people. So algebraically, I asked two questions. I first asked, is -6 in the image? And then the answer, we said no. And then I asked, is 2 in the image? And we said yes. So I'd like for you to consider, for example, these two equations right here, y equal square root x and y equal 2. Well, equality is transitive, which is to say that if square root of x is y and 2 is y, then 2 is the square root of x, right? So, which is to say something like, well, if I'm the same height as Fred, and Fred is the same height as Joe, well, I must be the same height as Joe, right? So if we take these two equations, those two equations, we can turn them into a single equation like this. And we can ask, does square root of x, the right side of that equation, equal to the right side of that equation have a solution? So that is to say, you're at the square root vending machine. What button, is there a button you can press so that the machine will vend to 2? You could press 4. So the answer is yes. So that would mean, therefore, we could say, therefore 2 is in the image. What's the question? So that's the question up here. What's the question corresponding to this? Right. Does square root of x equal -6 have a solution? And this time, algebraically, the answer is no. And we can say, okay, therefore, -6 is not in the image. Algebraically, the reason why square root of x equal -6 has no solution comes actually just straight from the definition, however many weeks ago when we wrote it down. And by definition, the output of a square root has to be greater than or equal to 0. That's just strictly by definition. So, visual question, algebraic question. Visual question, algebraic question. Good? Any question about this? Yes?
If we accidentally say because 2 is in the image,
not an image, would that still be correct, or do we have to say therefore 2 is an image?
Well, in fact, they're equivalent. So, but the flow of logic goes that way. By the way, this is therefore. And this one is because. In English, anyway. You know, this one is you know, from a mathematician's point of view, forward entailment, and this one is reverse entailment, right? Meaning that the implication goes that way, you know, forward in time, or you can point the implication the other way. Okay, so we asked a question about the image. The answer is that the image is y greater or equal to 0. Now we can ask a question, is it surjective? To make the vending machine analogy, again, the question of surjective is it the case that every item which is on display can be achieved? But in this case, the answer is no. The answer is no because, well, visually, we said that the range is this. We said that the range is all of this. So that's 0. But in the previous question, we calculated the image. And what's the image? Right. This is the image. And so the question of is it surjective is the same as asking, are these two the same? And the answer is no. So the answer to the question surjective is the answer is no. No, because the range is not the same as the image. Okay. Is it injective? It is. It is injective. The way you can see it visually, anyway, a way you can see it visually is you have a look at its plot, and then what's the visual question about its plot? How do you yeah? Right. You consider every horizontal line, and then you ask, is it the case that every horizontal line intersects 0 or 1 times? So 0 intersections, 1 intersection, and those are the only 2 varieties, right? Every horizontal line intersects at most once. So the answer to this question is yes, because of the horizontal line test. That's the plot, if you want to look at it visually, the question. But if you want to ask it algebraically,
what's, I'm sorry, ULT is?
That's supposed to be an H. Horizontal line test. So algebraically, the question is, well, how about the square root of x equal to a? How many solutions can this equation have? Well, it could have no solution if a is negative, meaning that that a is not in the image, or it can have exactly 1 solution. This has at most 1 solution. For all a. So to give specific examples, something like the square root of x equal -6, this has no solution. And the square root of x equal to, say, 2, this has one solution. And no other. So visually, the horizontal line test. Every horizontal line intersects 0 or 1 times. Algebraically, every equation either has 0 or 1 solution and no other possibility. Okay, great. Any question about square root? The main idea, the thing that you need to take away from it, is this picture.
In as much as that's what the graph of the square, or the plot of the graph of.
Yes.
Okay.
So you've got to know that's what it looks like. All the other things can be obtained immediately from it, right? So like, well, it's not at all necessary for you to think of it this way, but this is the way I think of it. I look at, in my mind's eye, I imagine the plot of the square root. When I ask a question about its domain, I make the plot fall down onto the horizontal axis. And then you see that much. It colors this.
You make the plot fall down, so you make y equals x, you make the half parabola.
Yeah, that's its shape.
Uh-huh.
And then that's the origin right there. And if all of those red points fell down, that's what you'd
And
see.
flattened out.
And flattened out.
Yeah.
Or you could think of it like these red points cast that red shadow
Yeah, they dropped, if they fell down and landed on the
horizontal
y.
axis. Similarly, the image is if instead of them falling down or casting a shadow that way, they cast a shadow that way. And that's what you see. That much. Yes?
If you're asking if it's injective, we only do the horizontal line test.
Yeah,
If
yeah.
you're asking if it was a function, or if the function was injective,
Mhm.
you would do the vertical line test. Right?
So let me try and I'm going to try and answer your question. So will it come to pass that I'll provide you a plot of a function and ask, is this function injective? In that case, so that will come to pass, and in that case, you'll draw a line or not and say it is or is not injective because of the horizontal line test. It will also come to pass that I'll give you a function to find and no plot and say, would you please show me whether or not it's injective? You almost always, in that case, algebraically, the answer is no, because it's far easier to say no, algebraically, than it is to say yes. So all you would have to do, like if we had an enormous vending machine with billions of buttons and billions of items on display, then to show that it is not injective, it's enough just to find 2 buttons and say, look, these 2 buttons, they're different buttons, and I press them and the Snickers comes out both ways. Whereas to show that it is injective, you'd have to one by one press every button. You'd have to say, now watch me. And like, meh, meh, meh. So does that answer it? Okay. So it's far easier to say no algebraically. Okay, so now the counterpart to square root of x is the squaring function. So now we're going to consider let f of x, instead of being square root, it's going to be x squared. The function that does, in some sense, the opposite thing. Okay. The domain. Well, no domain was explicit. Therefore, the domain of f is the natural domain of x squared which is what?
All reals.
All reals. So negative infinity, to write it with inequalities, negative infinity to less than x less than infinity. To write it as an interval, negative infinity to infinity. And then to plot it the whole shebang. Okay. The range. All reals. The reals, because why?
Range is not explicit.
Because it's not explicit. So transporting transporting ourselves back a couple minutes. Looking at these two sentences, they're kind of reflections of each other. We said there was no domain explicitly given, and therefore the domain is this. Whereas this one is structured differently. The domain is the reals because of this. So the implication is for this sentence is pointing that way. And for this one, it's going that way. So instead of writing because, in principle, I could have written this. But I tried not to make it too confusing. Okay. As a result, writing these three forms here, we could say negative infinity less than y less than infinity, negative infinity to infinity. And then as a plot, again, it would be the whole thing, but vertical. Okay, 3, the image. Okay, so we'll consider it, again, both ways. We'll consider it from the plot point of view. We already made a table of y equals square root x. In fact, at least once, I think twice in the semester. So I'll assume that you're comfortable with that. If you plot y equals square root of x, what is it that you see? In fact, a whole parabola, the whole thing. Right. So you can see the whole thing. Because you'll remember that when we made the table, the first time we were doing it, when we made the table and wrote the little red numbers on the bottom row, I said, oh, look, it's a palindrome like taco cat. You might remember I said that. The palindromicity, I'm not sure what you say there, of those red numbers makes itself seen in the fact that this is symmetric. So the right half looks in the mirror and sees the left half. So the question of what's in the image is, visually, for every horizontal line, which ones have an intersection? So these have no intersection. So none of this stuff down here is part of the image. The lowest part where there is an intersection is right there, and then we have intersection from then on. As a result, what's the image? Good. So y is greater or equal to 0. Written as an interval, 0 to infinity. And then plotted is what? Right, this much. So again, what I want you to see is that you have to collapse it from both sides, right? What if you were to take all this red ink in that picture and then just mash it, like just slap it all together. That's what you'd see. Everybody thinks about it differently, but I'll tell you that that's how it actually works in my head when I'm thinking about this. I take this and just mash it. Fine. Algebraically, the question, instead of asking which horizontal lines have intersection, the question becomes concerning the equation x squared equal a, for what a, for what values of a is there a solution? And the answer is, well, there's a solution if a is 0. The answer is 0. And there's 2 solutions if a is positive. For example, if a is 9, the 2 solutions are -3 and +3. It's the same question as asking. It's the same question as this. When this is y equal to a and a is negative, no intersection. When y equal to a and a is positive, there is an intersection. There is one. Okay. So at any rate, the answer to the question of what's the image is this. These ones. Next question. Is it surjective? It is not, because again, we just got finished saying these things. That this one is the range, and this one is the image, and the question is are those two the same? And the answer is no. So not surjective. Because range is not image. Now, that being said, I want to point out something. So this is an aside. If in a different context we said let g of x equal x squared with range (0 to infinity), that is to say, now we're talking about a function g, and the range is given, right? In this case, this g is surjective.
Simply because you changed it.
Yes. Because that is like, to make the vending machine analogy, that is like you going up to a vending machine, finding your favoriteest candy bar, and coming to discover that in fact there's no button that gives it that you can press to get it, and then you make a complaint, and you say, hey, I want to be able to get that candy bar. It disturbs me that candy bar is on display and I can't get it. And then as a result, some unhelpful technician comes in and removes that candy bar. Problem solved, right? No, I wanted you to wire up a button. But they just removed it. Well, that's what this is. 5. Is it injective? The answer is no. The answer is no because, well, visually, if you draw a plot, then what's the question? How do you address the question, is it injective?
Are there solutions? Is there at most one solution?
Is there at most one solution? That's algebraically, but how do you? And I agree with that. But how do you deal with that?
It's y across the parameter effect more than once.
Right. You draw a horizontal line and ask, is it the case that every horizontal line intersects at most once? And the answer to the question is no. So the answer to the question of is it injective is no, because it fails the horizontal line test. And you can see that right there. The horizontal line test says that at most one intersection is permitted. From an algebraic point of view, the question is, you considered this equation. So writing this is y equal a. And this one is y equal x squared. So again, if y is x squared and y is a, then what? Then a is x squared. So now we're asking, concerning this equation, does this equation have at most one solution for all a? And the answer is no, because we could consider the specific example of x squared is equal to 16. That is to say, what if a is 16? Then the answer is no, because this one has two solutions. Okay. Any question about this? All right. Good. So now we considered the square root function, and we considered its counterpart, the squaring function, and we considered them separately. But now I want to make some considerations about them when we have them at the same time. What if we considered them both? This and this. Now, visually, if you plot the square root function, it looks like this.
Should that be x squared up there?
It should be. I left off this 2 right here. So that's y is the square root of x. So now I'm going to plot y is x squared, but rather than plotting all of it in red, I'm going to plot the right side in red, and I'm going to plot the left side in green. But before I plot the left side, I want to ask the question, is it possible to take the square root function, imagine that we could pick it up and do what we want with it. Is it possible to pick it up and set it to where this red will line up with that red, will match it exactly? Yeah, that is possible because, for example, I can illustrate it right here. So here's this, and here's the square root. Now if I draw this line right here, and you imagine this to be a device, if I grab it right there and twist it over, then what you'll see is that. And the reason why that's the case is because Can you see it? So now I'll draw the rest of the parabola. What I want you to see is that if you were to take this plot and do the twisty thing, right, twist it and then set it on top of this one, so take this one and put it on top of that one, it would all of this would have a place to rest. You know, you could get the red parts to line up. But in fact, you can't do the other way, which is to say, if you took this one and twisted it and tried to set it on top of that one, the green would have nowhere to go. Right? It doesn't fit. This one will fit onto that one, but not the other way around. Now, well, suppose that we took this one and we said, well, I know that it won't fit, but I just want to see what it would be like if we tried to make it fit. If you took this red and twist and turned it so that this red would line up here, where would the green part be? Right, it'd be right here. It would be like that. Okay. So I have a question. Let's go back in time for a moment. And I asked the question about parabola and said, one of the question that was asked was, is it injective? And the answer was no. So we can see that it's not injective because of this, right? So this line, that line, shows us that it is not injective. Not injective. So now I'm going to cover that part up, and I must ask a different question. Concerning this plot here, which now consider it to have no, I just pulled it out of the hat. Is this plot the plot of a function? We've got a good reason for it not to be.
No, it's not. It's not.
It's not a function. Why not?
Because it doesn't pass the vertical line test.
It doesn't pass the vertical line test. Right, the vertical line test says that a plot is the plot of a function when every vertical line intersects at most once. So what this line is saying, if it's saying anything, you could take this line to be saying that, well, this is not a function. Okay, so this line is saying it's not a function. That line is saying it's not injective. Now, suppose that I do this. In case you can't tell what I'm doing, I'm tracing. Oh, I want that to be big. So here's my question. When you take this red, and twist this one so that it would lay on top of that, you'd see that, right? The red twists to here, the green twists to here. My question is this line that's saying not injective, where does it twist to? Where does this line go? Is that line. It's that line because so what I want you to see is that this twist, whatever, we don't have a good name for it yet, but there is a name, and we'll get to it eventually. This twist is saying that, well, if you start out with a function that's not injective, and you do that, you're going to end up with something that's not a function. If you start with something that is not a function and do a twist, it might end up being a function, but it's definitely not going to be injective. Interesting. So the fact that you can get this much red to twist onto that much plot, that is possible. But the fact that you can't get this much plot to twist and lay only on top of this one, that's the reason. That's the reason why the square root of x squared is the absolute value of x. That's the reason why. And it is also the reason why, if you do those in the opposite order, the square root of x first and then square it, what's that? Just x. Those are manifestations of the observation that, oh, you can twist this red onto that one, and it fits. But you can't take all of this and twist it and make it fit there. That's the visual reason for that unexpected algebraic asymmetry. Okay, good. That's all the time that we have for today. So I hope you have a wonderful weekend.